My name is Corey Herder. I'd like to welcome you guys out tonight to the this advanced level of sacred geometry, solid advanced information and science for how the programmers work. This book here, called The Perfect Wave, is the scientific half of my work. The other book is Visions of Heaven. That's my story. This book is all the science behind how the programmers work. So it gets into all different types of levels of physics, memory systems, consciousness, neurology. That's what we're going to go through tonight, and I'm going to teach you guys about. Soon this book will be on the website as well. It's always much easier to learn this information than it is from a book, though. So it's going to be great because we'll have the book to follow up with after you watch the video or watch the seminar. So that's going to be a great addition to the website for you guys to learn. We're going to start out just doing a quick review of pyramid energy and where it all starts from. Pyramids, there's always something very unique about the capstone. Capstone is always known as floating, or there's a little eye in it, or sometimes the capstone is the eye. Either way, there's something fascinating about the capstone. We don't really know what it is till we decide, hey, you know what, let's just get rid of it altogether. We draw a pyramid from the top with the capstone missing. It looks like this. If I draw 6 of them, all with their capstone missing, we get the shape of a cross, which is a very powerful symbol. If we fold all these pyramids in towards the center, you end up with a cube. Keep in mind that the pyramids have to be all at a 45-degree angle in order for this to work, in order for the cube to fit together, so they all fit together perfectly. Inside this cube, where the capstones are all missing, we have an empty little cube inside the center. We now know that on top of the pyramid is a cube. As soon as a pyramid has 3 sides, 4 sides, which is a standard type of pyramid that we're used to seeing, 5 sides, 6 sides, 20 sides, or even a cone, which is all round. It's a regulator for how fast that pyramid's spinning. The faster it spins, the more energy it gathers up and sucks into the capstone. Now, the capstone is a pressurized system. As the energy is drawn into it, it pressurizes this cube, pushes the sides out, turns it into a sphere. Once the amount of energy coming into the capstone matches with the energy coming out of the capstone, the energy reverses direction and a beam of energy shot down throughout the middle here. Okay, this is how a pyramid focuses energy. As the energy loses momentum, it spreads out. This spreading out if I draw this pyramid a little bit differently, just upside down basically, it looks like this. If I draw it this way, we get a little flower. This is basically considered the flower of life. Okay? It's the law of physics that generates the flower. Now, a pyramid, of course, sucks in energy into the capstone, pressurizes it, and shoots this energy out in a concentrated beam. Well, leaves suck in carbon dioxide, pull it in to the seed or root system, convert the energy, and shoot it back out through the tip. which would be oxygen. So a pyramid draws an energy, converts the energy or the vibration through the capstone, shoots that energy back out. Once it loses momentum, it spreads. Flower sucks in carbon dioxide, converts that to oxygen, shoots the energy back up and out through this stalk, up through the tip of the flower. Depending on the tip of the flower is how the energy disperses. This same spreading feature. This is a law of physics. And not just physics, it's a law of nature. This law runs through every different system that we can find. Consciousness, science, biology, medicine, religion. It runs through everything, this law. It's massive. What we're going to look at is this seed here. That's what we're going to look at tonight. The seed and the root system. Okay? So that's one of the most important parts. To start off with that, let's figure out what that root system does first. So we're going to take the pyramid. There's the capstone. We're going to learn that you take this capstone, you take this angle right here, this angle, and you take that angle, you divide it by 2, and that equals your vibration, your degree of vibration. This one here is a 60-degree angle. Divide that by 2, you get a 30-degree vibration. This here is a real fat pyramid. We'll call this 140 degrees. If you measure this, we're going to divide that by 2, and we end up with a 70-degree vibration. That's all it is. Okay? This very first measurement of what type of vibration is produced from the capstone is just simply that. Measure this angle divided by 2. From here, we can map that vibration. (30°, 70 degrees). Okay? If I draw this 30-degree one out, and I'll draw the 70-degree one out. Okay, we got that. If I add in an extra line, we start to get things that look very similar to DNA. Why would we add a second line though? With electricity, there's 3 types of circuits. There's probably more than 3, but there's 3 basic ones. Open circuit. I also call this an open string. Basically, you have a start and you have an end. The energy starts from here and it ends here, and that's it. It's finished. You have a closed circuit, which is a circle. It's a loop. The energy starts somewhere and just keeps going and going and going and going and going. Example of that, it's like your heartbeat, your breath. It's always going, non-stop. Okay. There's a third type which combines these 2, and that's considered a parallel circuit. The great thing about this is that this one circuit allows for both of these to take place and to happen. So this energy can come up this direction and go straight up and complete itself, and that's it. It's finished. It can also go loop and keep looping. Okay? So this is a parallel circuit. As soon as we twist this a little bit, we end up with this shape. Okay, which is DNA. It's a very efficient energy transfer circuit. Okay? We know that DNA and vibration are very matched because of the basic geometry. But we also know that they're very